Hello and welcome to the third video in the numbers overview of GCSE Maths. Today we're doing factors, multiples and primes. If you're watching this on YouTube, you can scroll down into the description and you can find the link to our website, which will take you to all of the question papers and mark schemes for that question paper with regards to factors, multiples and primes. After you watch this lecture, I highly recommend you have a go at those questions so that you can consolidate this knowledge and make sure that you have learnt everything I've taught you here. And make sure you do look at the mark scheme to then mark your work. If you're watching this on my website, on the teachably.co.uk website, then if you scroll down a little bit, you are also going to see the question paper alongside the mark scheme. So again, please make sure you go ahead and attempt those questions once you've watched this lecture. And at any point, if you do struggle and you find yourself stuck, you can always reference back to this video. So we're going to be looking at factors, what they are, multiples, what they are, and then common factors and multiples, which is a big topic that overlaps with many other further topics. We're going to look at prime factorisation, which again is very helpful, and then we'll look at some worked examples and things to avoid. So an overview really, factors, multiples and primes. Factors, multiples and primes, right, and also prime factorizations, they come up constantly. Okay, so both as direct questions, especially these right here, common factors and multiples and prime factorization, and as well as hidden skills behind other topics. And these are like HCF, so highest common factor and lowest common multiple, LCM, you know, things like simplifying fractions, which is the next topic after this, and even surds, which is one of the higher end topics, like in the range of 7 onwards. So this lesson, it covers listing factors and multiples, finding common factors and multiples, and then breaking a number down into prime factors. And so these are all techniques and things that you should carry forward in your GCSE Maths journey. So please pay attention to this lesson as it's going to have a lot for you moving forward. So the first thing we need to look at is things called factors. So a factor of a number divides into it exactly with nothing left over. Some examples. The factors of 18 are 1, 2, 3, 6, 9 and 18. Because each of these divides into 18 with no remainder. Let's do some examples. So if we take 18 and we divide it by one of these, let's say we divide it by 2. So 2 is right there in the list. 18 divided by 2, well, it's just halving the number, so that is equal to 9. And there's nothing left over. Let's try another one. Let's say 18 divided by 6, which again is a number on the list. How many times does 6 go into 18? Well, 6, 12, 18. So it goes in exactly 3 times. And again, there's no remainder. What would an example of a non-factor of 18 be? Well, if we divide 18, let's say by 5, let's divide 18 by 5. So how many times does 5 go into 18? Well, it goes once because it's 5, then twice because 5, 10, 15, and then you're going to overshoot to 20. And so we can say that 5 goes into 18 3 times, but then there's a remainder because that last 5 only goes 3 times into it before it overshoots by 2. And so this would actually turn into something we call a mixed number because it goes into it 3 times and then there's a remainder of 3 over 5. Okay, so there's 3/5 remaining. Now, we don't have to worry about this right now because we're talking about factors. But the point is, there are numbers that do not go cleanly into 18, whereas there are numbers that go cleanly into 18, such as 2, 6, 3, 9, etc. Okay, so now that we've got that out of the way, let's just erase all of this. Okay, so it doesn't want to listen to me. So list factors in pairs. So this is talking about the methodology of how we'd actually break a number down into its factors. Start at 1 and the number itself. So for 18 it would be 1 and 18. Then work inwards until the pairs meet or cross over. What do we mean by that? So this is a good example or a good illustration of what they're talking about. We want to look at all of the factors of 18. And so we start with 1 and 18. And we're looking at numbers that multiply together to make 18, because this is how we're going to get 18. So 1 times 18 gives us 18. Perfect. We now know that 1 is a factor and also 18 is a factor. Then we try something else, okay? 2 and 9 together, if you multiply them, they give you 18. So now we know that 2 and 9 are factors of 18. And then we try 3, and we know that if we take 3 and we multiply it by 6, we also get 18. And then if you multiply them together, you get 18. And so we now know that 1, 2, 3, 6, 9, and 18 are all factors of 18. Now, can we go further? Well, we can try. 4 times what gives us 18? I can't think of a number. You'd think 4 times 6. 4 times 6 is 24. Okay, 4 times 5 is 20. Okay, 4 times 4, that's 16. And so we can see very quickly that there's no factor 4. And then we can continue down the line and we can see there's no other factors. And so now we have the full list of factors of 18, which is 1, 2, 3, 6, 9, and 18. I'm going to do a very quick example of another number just so it's really solid. So let's try 20. So we want to look at all the factors of 20. So the first thing I'm going to do is try 1 times something to give us 20. Well, 1 times 20 is 20. And so straight away in our list of factors of 20, I'm going to say, well, we have 1 and we also have 20. Okay, so now let's look at the next one. Can we take 2 and multiply it by something to give us 20? Well, if I take 2 and I multiply it by 10, I also get 20. And so straight away, we now know that 2 and 10 are also both factors of 20. Let's try 3. Is there any number I take 3 and I multiply it by something to give us 20? Well, 3 times 7 is 21 and 3 times 6 is 18. And so very quickly I can see there's no number multiplied by 3 to give us 20. So we skip over to 4. 4 times something to give us 20. Well, 4 times 5 will give us 20. And so I also now know that 4 and 5 are also factors of 20. And then notice how if I go further down from 4 and I go to 5, I will also get 4 times 5, which is 20. But this is redundant. We don't want this because we already have 4 and 5 in our list. And so we don't have to repeat ourselves by saying 5 times 4 because it's the same thing. So we don't need this in our list. And then is there 6 times something? And you won't see it. And so if we wanted to put this a factor list in order, we can, which is 1, 2, 4, 5, 10, and 20. And now I can see that the list of factors of 20 is 1, 2, 4, 5, 10, and 20. And if you want to put it in order, always just go down here and then take a right and then go up from here. So that is how to find the factors of a number. And hopefully you understand what a factor is, because any of these numbers that we have listed, we can divide into 20 and it would give us a whole number. I'll just give you a very quick example. If I do 20 divided by 5, right? 20 divided by 5, that's going to give us 4 and no remainder. Okay, so once you found your factors, you now know everything that divides into that number nicely. Moving on, multiples. So multiples are sort of like cousins of factors and a lot of people tend to confuse them. So let's try making sure that it's very coherent which each of these are. A multiple of a number is what you get by multiplying it by a positive whole number. So, for example, the first 5 multiples of 6 are 1 times 6, which is 6, so right here, and then 2 times 6, which is 12, which is here, then 3 times 6, which is 18, which is here, then we have 4 times 6, which is 24, which is here, and then we also have 5 times 6, which is 30, which is also here. And so what this is trying to show us is that the multiples of a number are just 1 times that number, 2 times that number, 3 times that number, 4 times that number, 5 times that number, and so on. And you can make this list as long as you want. We can go up to the 10 multiples, up to the 20 multiples, etc. Now, this key thing right here is 3 is a factor of 12, but 36 is a multiple of 12. So, what's that actually telling us? That's telling us that if we take 12, we can divide it by 3 and get a whole number, which is 4. But how about on the flip side? What's it trying to say with 36 being a multiple of 12? Well, if we take 12 and we multiply it by 3, so 3 times 12, we will get 36, right? And so all this is telling you is that 36 is a multiple of 3 because it is a multiple of 12, sorry, because if you go along the list, if you go 1 times 12, you get 12, 2 times 12 is 24, 3 times 12 is 36. In that list of numbers, you're going to find 36. And so it's an example trying to show you that 12 can have a factor, right, of 3. But then if you also take 3 and multiply it by 12, you'll also get a number in its multiple list. And what this example is trying to show you is that there is a subtle relationship between factors and multiples, and we're going to dive into that in the next slide, but I just want you to keep that piece of information in mind, okay? So really just to sort of solidify this, a factor divides in to a number, and a multiple is what you get by multiplying that number. So keep these things in mind. Common factors and multiples. Okay, so welcome to the relationship between factors and multiples. As I said, let's read the slide. So a common factor of two numbers divides into both of them exactly. So 6 is a common factor of 12 and 18 because now if you take 18 and divide it by 6, you get 3. But if you also take 12 and divide it by 6, you get 2. And so that means the number 6 divides into 18 and into 12, and therefore 6 is a common factor between these two numbers. Okay? Now a common multiple of two numbers appears in both of their times tables. 12 is a common multiple of 4 and 6. What does that mean? So this was the example for the factors, but for the multiples, let's have a look. So if we look at 4, what are the multiples of 4? Remember, you just go down multiplying that number. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and 4 times 4 is 16, and we can keep on going. The reason why I stopped is because it was talking about 12, and we already saw 12 in our list. So I'm going to highlight that. Then if we look at the multiples of 6, we start off with 1 times 6, which is 6. And then we say 2 times 6, which is 12. And then we do 3 times 6, which is 18. And then we can do 4 times 6, which is 24. And again, that goes on. But then as we can see in our list of multiples, we also have 12. And so if you want to find a common multiple between two numbers, you can very easily just list out those multiples and then see is there any numbers common in those lists, and straight away we saw 12. Okay, so if we look at the factors of 12 and 18, we can actually draw a Venn diagram, and this is going to be very important for later topics like HCF and LCM. So 12, the factors of 12 are 1, 4 and, well actually let's write out the multiples of the factors of 12. So 12 we know is 1 times 12, we know is 2 times 6, and we know is 3 times 4. Those are all the factors of 12. So we've got 1, 2, 3, 4, 6, 12. And then we can also look at 18. 18 is 1 times 18, 2 times 9, 3 times 6, and 4 times, was there something else? Not to my recollection. Okay, so we'll keep it there for now. So the factors of 18 are 1, 2, 3, and 6, 9, 18. So now, if we look at the Venn diagram, we are going to put on the left side what 12 only has, on the right hand side what 18 only has, and in the middle what they both have in common. And so right now we can see that 1, right, is in 12, but it's also in 18. And so if we put it right, I think they've done it. I think the slides are slightly wrong here. So I'm going to just draw my own Venn diagram right here. So we're going to call this one 12 and we're going to call this one 18. And so I'm just going to list off the things as we go along. So 1, go in the middle because it's in both. 2, because they both have it. 3, they both have it. So I'm going to put that in the middle as well. Then we can see that 4 is only on the 12 side. So I'm going to put a 4 there, dash it off. Then we can see that they both share 6 as well. So I'm going to put 6 in the middle as well. 6 like that, dash that off. Then I can see 9 is only in the 18 side. Then I can see 12 is only in the 12. And I can also see that 18 is only in the 18. And so this is how your Venn diagram really should be drawn, because in the middle it's all of the common factors, and on the left and on the right is all the factors that are only unique to 12 and 18. That's how you really should draw it. This was sort of messed up. Hope that makes sense. Let's move on. Find a common multiple of 4 and 6. So I'm just going to read out the methodology and then I'm going to give you the example. Number 1, list the first few multiples. So for 4 is 4, 8, 12, 16, 20. List the first few multiples of 6, 6, 12, 18, 24. Compare the two lists and 12 appears in both, so 12 is a common multiple. And so really and truly for 4, you're going to do 4 times 1, you're going to do 4 times 2, you're going to do 4 times 3, you're going to do 4 times 4, you're going to do 4 times 5. And like I said, onwards, for 6, you get 1 times 6, 2 times 6, 3 times 6, 4 times 6, so on and so forth. And then, like they said, we can very easily see that 12 is the only common thing in both of these lists. And so 12 is a common multiple of 4 and 6. So these are things that you need to make sure that you're able to do very quickly. So these are building blocks. Prime factorization. Now, prime factorization is very important. So let's read this out and then I'll give you the example. So every whole number greater than 1 can be written as a product of prime numbers, and there is only ever one way to do it. Okay, what does product mean? Don't worry too much, but in reality it just means multiplication. This is usually found with a factor tree. A factor tree is a method to get the prime factorization, and I'm going to teach you how to do it. You split the number into any 2 factors and then you keep splitting until only prime numbers remain. Remember in the previous lesson when we were talking about prime numbers, numbers that only have 1 and itself as factors. So this is linking to the previous lesson as well. The final answer is written in index form, and I'll speak to you about that, collecting repeated primes together. So let me give you an example before I talk about this illustration. Let's try to break the number 24 down into its prime factorization. So if we take 24 and we're told to do a prime factorization of this number, we are going to use the tree method, the factor tree method. What does that mean? We're going to write 2 or draw 2 things coming out of it, and then we are going to write 2 factors of that number that multiply to make 24. I'm going to keep it very easy, so I'm going to say 2 times 12 makes 24. So 2 times 12 is going to give us 24. Now, at this stage, we want to circle every single prime number, because a prime number can't be split any other way than 1 and itself. In this case, it's 1 and 2. And we don't want to do that because it's redundant, it's just wasted work, because we're getting a 2 repeated there, and we don't need to do that. And so I'm going to circle a prime number, and in this case 2 is a prime number here. 12 is not a prime number because we can break it down into other things besides 1 and itself. 12 can be broken down into 3 times 4, and then again every stage we look at prime factors or prime numbers. 4 is not a prime number, but 3 is a prime number because 3 can only be broken down into 1 and 3, nothing else. And so we circle that. We don't have to go down these trees, we just circle them. And then 4 can be written as 2 times 2. And so I'm going to circle those because we know those are primes. And so we've now taken 24 and we've broken it down into 2, 3, 2, and 2. When it says index form, what it means is now you take all of the circled prime numbers and you multiply them together. So we have 2 times 3 times 2 times 2. Now, if you go into your calculator, or if you do it in your head, you can very quickly see that 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24. And so we now can write a list of prime numbers being multiplied by each other together, giving us our number 24. Now, until you go further into mathematics and into theorems at university level, you don't have to go any further than this, but this is unique for every single number. You are not going to get the same repeated prime factorization for any other number. This is completely unique to 24. You are never going to get this repeated for any other number. Now, a nice way to write this is using powers, because we can see that we've got 2, 2, and 2. So we've got 2 3 times. And so it'd be nicer to write it out as 2 and then to the power of 3. Rather than writing 2 out 3 times, we just say, well, we're going to end up multiplying 2 by itself 3 times. So it's nicer to write 2 to the power of 3 and then multiply that by 3 because we've got this 3 left over. And so our prime factorization really is 2 times 3 times 2 times 2. But a nicer index form way of writing this is 2 to the power of 3 times 3. Okay, now we can talk about this because we've learned the mechanics. If we want to work out the prime factorization of 60, we do the same thing. 60 is here, and then we can say 2 times 30, and then we circle the 2 because prime. 30 can be broken down into 2 and 15, so 2 times 15 makes 30. Again, we circle the prime, and then 15 is 3 times 5, and both of those are primes, and so we can take these primes, multiply them by each other, so we can say this is 2 times 2 times 3 times 5, and then a nicer way to write it is, because we've got 2 repeated, we can say 2 to the power of 2 times 3 times 5, and so our final answer would be 60 is the same as 2 squared times 3 times 5. Okay, that's prime factorization. So really you just keep splitting until only primes remain. Very important technique this. Keep on rewatching this section if you don't get it. Now, we want to list the first 5 multiples of 6. This is an exam question or something you might get at the beginning of a foundation paper. What are we going to do? Well, we're going to take 6, we're going to multiply it by 1, we're going to take 6 multiplied by 2, multiply it by 3, multiply it by 4, multiply it by 5. And that is how you get the first 5 multiples of any single number. And this is the methodology of how to get that. And so how would you write that on your answer line? You'd write 6, 12, 18, 24, and 30. Moving on, write a common factor of 12 and 18. Again, let's write out all of the factors of 12. So we take 12. We want to break it down into its factors, so 1 times 12, 2 times 6, 3 times 4, and we now know that 1, 2, 3, 4, 6, and 12 are factors of 12. Then we can look at 18, we can say 1 times 18, we can say 2 times 9, and we can also say 3 times 6. So now we know that 1, 2, 3, 6, 9, and 18 are factors of 18. We want to know the common factors of 12 and 18. So what's common between these numbers? Well, we've got 1 in both lists, we've got 2 in both, we've got 3 in both, and we've also got 6 in both as well. And so what we can say is the common factors of 12 and 18 are 1, 2, 3, and 6. These are all factors that are factors of 12 and also of 18. Now, the question says a common factor of 12 and 18. And so you didn't really have to give the full list. You could have just given 6 or 3 or 12. Now, if you look at the question, if you look at the answer, sorry, it doesn't list 1. Okay, that's very important because 1 is almost redundant because 1 appears in any number, even if it's a prime number. If you took a prime number 2, you said that's 1 times 2, and then you took a prime number 3 and said 1 times 3, well, you can say they have a common factor of 1, but it's kind of redundant because it's just a unit. And so the reason why it doesn't list it here is because of that reason. You'd rather list anything above 1. And technically, 1 is included, but really you shouldn't include it. So I hope that makes sense. So let's move on to the harder question. So now it says, do the prime factors of 72 in index form. So what does it mean when it says write down the prime factors of 72 in index form? All you do is you do the tree method like I showed you. So we take 72, okay? And we say, well, 72 is 2 times 36. 2 is a prime, so we circle it. 36, now you can do it any way you want. You can do 2 times 18 if you want. I'm going to write it out as 6 times 6. Now, none of these are prime, so we can break both of these down. 6 is 2 times 3, and both of those are prime. And then 6 is also 2 times 3, and both of those are prime as well. And so that's our factor tree right here. And we can say that, therefore, 72 is equal to 2 times 2 times 3 times 2 times 3. Just going in order. And then if we want it in index form in a nicer format, well, let's say we've got 2 to the power of however many 2's we have. So we've got 1, 2, 3. So 2 to the power of 3, or 2 cubed. And then multiplied by, well, 3. And how many 3's have we got? We've got 1, 2, 3's. So we can say times 3 to the power of 2, or 3 squared. And so the prime factorization of 72 in index form would be 2 cubed times 3 squared. So the answer, 2 cubed times 3 squared. I hope that makes sense. Now, in terms of things to avoid for this topic, confusing factors and multiples, very common, right? So as long as you go back to the beginning of this video and you watch the factor section and the multiple section, hopefully you won't confuse them again. But it's very common for people to mix these two together. So make sure you're not one of those people. For example, listing the times table of a number when asked for its factors. Remember, a factor goes into the number, and a multiple is when you take it, a number and multiply it by 1, 2, 3, 4, 5, 6, 7. Forgetting to include 1 and the number itself when listing all factors of a number. So remember, 1 is always going to be a factor of any number, so remember to keep it in the list. Number 3, stopping a factor tree before every branch ends in a prime number, leaving a non-prime factor in the final answer. So an example of that would be if we just kept it as 6 times 6 and then we circled those. Clearly 6 and 6 can be split into 2 times 3, 2 times 3. So we keep on going until there's only primes at the tips of those branches. Number 4, writing out the full multiplication instead of index form when index form is specifically asked for. So that example would be if we left our prime factorization as this, when the question asked for index form. Index form is when you take the numbers you have and then simplify it into powers. Okay, now I just want to make a very quick thing, is because if your prime factorization, let's say, was 2 times 3, let's say 2 times 5 or something, right? And that was the only prime factors you had, then that would be index form. That is the simplest way you can write that. You can't write 2 to the power of 1 or times 5 to the power of 1. You're just going to keep it as 2 times 5. So this would be index form. but that's because it's the simplest way of writing it. Whereas this is its simplest way because you've not repeated the 2 or the 3 more than once. And then the final thing is, when asked for a common multiple, giving a multiple of only one number of the 2 numbers instead of both. So very quickly, instead of, if we're told write the multiples, the common multiples of 6 and 18, and you just wrote 6, or you just wrote 12. That's a multiple of 6, but it's not a multiple of 18. Okay? Final words, factors, multiples, and prime factorizations, they are the toolkit, right, that so many other topics quietly rely on. Just like any of the other foundational topics we're doing in this number overview. Okay, so think about each of them as a skill that you will keep reaching for, long after this lesson, even into HCF and LCM and surds and simplifying fractions. They all use common factors and common multiples, so we are going to use them. So you can apply them whenever you spot the certain conditions for each. And honestly, like most things in maths, it's all about practice. So if you can finish all of the questions in the practice paper I told you to look in the description or at the bottom of our website, with the mark scheme, that we've prepared for you, then you're all set. If you do need GCSE Maths tuition and you want myself to tutor you personally to get a high grade that you're wanting to achieve, or even to just boost your confidence to show you that maths is not as intimidating as most teachers make it out to be, then please book a call with myself, or you can just text me on Instagram or TikTok. DM me, reach out, ideally with your parent, and ask, and then of course we'll make sure that we're able to accommodate for yourself. And whether it's me or a team member of Teachably that teaches you, you are going to get the same rigorous process, systematic process that we've been doing for the past 7 years to ensure that you get the grades and you understand the maths the same way many of our other students have. If you want to look at the testimonies on our website to verify that. Hope you have a lovely day, and thank you for taking your time out your day to ensure that you learn this maths. Take care of yourself, and I'll see you soon. Bye.